I'm live and you can hear the music, Oppenheimer, and we'll just dive right in. Let me fix a few things. Yes, Postman. And yep, Boot.dev. And today we are going to do object oriented programming. Yep, in Python. Start the course and let me explain these things. First, what I know about them. Classes. Classes are things, a method of representing a data structure which also contains the functions which are supposed to run on those data structures. And those things are called classes. Encapsulation means that everything that you need to deal with that data structure, everything that you need to deal with that data structure is within the class. And my screen is stuck. My bad. Wait. Yep. Um, Screen and it always gets stuck. Yep, now it is fine and shit. Oh, music was too loud. Now it is fine. And let me reduce it a bit. Yes, encapsulation. Encapsulation means that everything that you need to work with the class, the functions, and you wouldn't need anything else than the functions, is within the class itself. So it is encapsulated. Everything that you need is within itself. Abstraction means that to work with the data that is in a class, you do not need to know the inner workings of the functions that are provided by that class. You only need to know the interface, and that is all. So if you want something done with the class, you can just call the function, and you don't have to care about how that thing is achieved. That is all. And inheritance means that if you have a class which has certain data points and certain functions, but you want to add more data points and more functions to that, but you also want the original ones, there is a concept called inheritance in which you get the data points and functions defined in a class and add on top of those. Add more additional data points and additional functions to that and make a sort of super class which has the properties of the original class and the additional ones that you added. And polymorphism means that when an operator is overloaded with more than one operation. For example, in Python, you can use the plus operator to add two integers and also to join two arrays, I suppose, and to concatenate two strings. That is polymorphism. Polymorphism is one of the best ideas we have had in developers as developers learn how it works. Okay, now the course. Shit. What is object-oriented programming? OP is a pattern for writing clean and manageable, maintainable code. Not everyone agrees that object-oriented principles are the best way to write code, but to be a good engineer, you should at least understand them. In this course, we will be coding the piece of a real-time strategy game called Age of Dragons. Players control armies of people, elves, orcs, and dragons and battle each other. It's time. It is similar to Age of Empire or StarCraft assignment. One of the greatest sins when trying to write clean code is using misleading names for your variables and functions. Take a look at a destroy wall function. Based on its name, you might assume that it destroys a single wall, but if you look closely, you will see that it handles multiple walls. Destroy walls and destroy wall, that is the function, and that takes in wall health. For W in wall health, if W less than 0, wall health dot remove W. Shit, it takes in multiple walls. It takes an array of walls of wall health. The test suite expects a different function name. Take a look at main test.py file to see if it is looking for to see what it's looking for and rename the function accordingly. What is the main function looking for? Run cases and destroy walls S. That is it. Yep, destroy walls and run maybe. Additionally, zero failed, so submit would work. Yep, it does. Clean code. Paradigms like object-oriented programming and functional programming. I don't know how you would define functional programming, because functional programming is just writing functions and giving in parameters to those functions to work with. But in object-oriented programming, they are replaced with methods, which are called upon basic objects, and those methods can be called without initializing an instance of that object of that class, which is, what are those methods called? Inherent or inbuilt something they are called, are all about making code easier to work with and understand as the feeble humans we are. Code that is easy for humans to understand is called clean code. And Martin Fowler. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. Martin Fowler, isn't he Uncle Bob? Martin Fowler, software developer and author. Nope, he is someone else. He has written books. Yep, about paradigm patterns of enterprise refactoring. Refactoring device. Clean code does not make your program run faster, make your program run correctly. Only occur in object-oriented programming. Clean code does make code easier to understand, easier to work with, makes it easier to find and fix bugs, make the development process faster, helps us retain our sanity. Clean code maintains your program fun enough, makes the game you are developing more fun enough, is easy to work with as a developer. Can only be written by Uncle Bob. Yep, that is what I said. Uncle Bob. Clean code, and that is the same thing. And the primary goal of OOP is to write faster code. That is here. Write cleaner code. Yep. Store less data. Objective are people. Write faster code. Write cleaner code. Both of these are true. Primary goal. Primary goal. Primary goal. Primary goal. Cleaner. Yes. Faster. We can doubt, but cleaner is, of course, one of the ways. Try. Don't repeat yourself. Another rule of thumb for writing maintainable code is don't repeat yourself dry. It just means that when possible, you should avoid writing the same code in multiple places. Repeating code as can be bad, because if you need to change it, you have to change it in multiple places. If you forget to change it in one place, you will have a bug. It's more work to work it over and over again. Assignment. Your manager noticed that there is a lot of repetitive code in Age of Dragons codebase. She asked you to update the fighter soldier function so that DPS, damage per second, calculation is only written once. Write this write this into one line. Okay, these are identical line. Create a new function called get soldier DPS, damage per second. Take a um, that takes the soldier and returns its DPS using the same logic as the lines above. Replace the two lines above with the calls to get soldier DPS. All right, get soldier DPS, that takes in, what does it take in? It prints soldier 1 DPS is soldier 1 DPS damage soldier 1. Okay, it just takes soldier 1, an array, then soldier, it takes in soldier and return soldier, shit, soldier bracket damage multiply by soldier bracket attack per second. and replace these two. Soldier 1 DPS equals get soldier DPS with soldier 1 and soldier TWO DPS equals get soldier DPS with get soldier what with yep soldier 2 and run if it works. 2 failed. Shit, it does not work. I created a new function and replaced the two lines with the calls to get soldier DPS. Get soldier DPS. It takes in soldier and returns this. Input damage 10 attack per this expected attack per second. I have to return this soldier into damage. Soldier's damage into soldier attack per second. Attacks. My bad. Attacks per second. My bad. That does work now. Moving on. Dry, that is the same thing there. Dry stands for don't repeat yourself, don't shave yaks, don't do drugs, DDD, don't repeat yourself, don't repeat yourself, do repeat yourself. Okay. Oh, nope. Dry code does not make your code shorter and easier to read. It does make it shorter and easier to read. Make your code run faster. It says does not make your code run faster. Make your code easier to update. Make fixing bugs faster. You only fix them in one place. Now next. Classes. A class is a special type of value in an object-oriented programming language like Python. It is similar to a dictionary in that it can usually store. Wait a minute. Maybe it is getting a bit too loud. It is getting a bit too loud for me. Interstellar is good. It's like slow music and everything. Oppenheimer is better for, I guess, physics. It is similar to a dictionary in that it. I thought I was stuck. A bit slower, like not slower, but lower volume. It is similar to a dictionary in that it usually stores other types inside itself. Yep. Health is this, and this is how we define a class. The class name, and then this. Just like a string, integer, or float, a class is a type. But instead of being a built-in type, your class are custom types that you define. An object is just an instance of class type. An object is just an instance of a class type. That is, a class defines a structure, but an object is a instance of that structure being implied somewhere. Health is 50. Health is an instance of an integer type, and soldier arrogant is an instance of the soldier type class. Makes sense. Classes are custom new types that we define as programmers. Each new instance of a class is an object. Each new instance of a class is an object. Yes. Class archer creates several instances of archer, which is just two. And then I can do this. Health and arrows. Create a class called walls on line 1. On Okay, it is there, and I have to replace pass with a property called armor that initializes to 10 and height at 5. Okay, and that does run. Should have run. Yep. Now, methods. After last exercises, you might be wondering why classes are useful. They are just dictionaries, but worse. Yep, one thing that makes classes cool is that we can define methods on them. A method is a function that tries to directly, that is tied directly to a class and has access to all its properties. Yep. Health is 5 and def take damage. Self means the instance of the class that is running at that time, and additional parameter that will be given by the user when it is being used, and it will reduce health damage, subtract damage from whatever the health is at that time, and it does not specifically mean 5. It means the health that would be associated with that in particular instance of this class. Yes, this is initializing and instance of that class called an object, and then doing some damage, then printing health, which is 3. Self. Methods are nested within the class declaration. Nested, nested. Within the class declaration, their first parameter is always the instance of the class. Yep. Instance of the class that um, method is being called on. And it is much easier to work when you are not trying to find out how exactly it is being managed. If you can just treat stuff as black box and accept it and have belief that there is no magic and some logical thing, complicated logical thing is going on under the hood, and you can just work with it without your brain aching. By convention, it is called self because self is a reference to the object. You can use it to read and update the properties of the object. Notice that methods are called directly on an object using the dot operator, like that. Assignment: add a 45 method to your wall class. It should double the current armor property. 45 self, it does armor multiply equals to run. That should work. Fucking hell. 45. My bad. Self dot armor run. Yep, that does work. Moving on to the next lesson: methods return values. Yes. If a normal function doesn't return anything, it is typically not a very useful function. If it does not return something, then it is mainly used for its side effect. In contrast, methods often don't return anything explicitly because they can manipulate the properties of the object instead. That is exactly what we did in the last assignment. However, they can return values if you want. They are just functions and with access to an object after all. Soldier, it has an armor and number of weapons. Get speed. Speed is 10 and okay, speed is reduced by the number of weapons and the armor, and it returns speed. Soldier 1, get speed, prints something. Add a get cost function to your wall class, this wall class. What do you think it should return? The cost of the wall is the product of its height and armor. Product of its height and armor. Don't touch the code below this line. Shit, my bad. Return self dot armor multiply self dot height, and that does work. And moving on to the next lesson: methods versus functions. Not exactly different, but methods also have access. No, methods do not have access to. They have the context that they are called in is the context in which they are called in, but methods are called in the context of the object in which they were defined. Is that is the difference? You know what a function is? Method has all the same properties as a function, but it is tied directly to a class and has access to all its properties. A method automatically receives the object it was called on. as the first parameter, like this. Um, Class health is 5 and take damage, self damage multiplier, damage multiplier, and self health and decrease the damage from them. From that, Darlin, Dalinar, Dalinor, and do this, and then give damage. A method can operate on data that is contained within the class. In other words, you won't always see all outputs in the return statement because the method might just mutate the object's properties directly. Object-oriented programming debate. Because functions are more explicit, some developers argue that functional programming is better than object-oriented programming. In reality, neither paradigm is better, and the best developers learn and understand both styles and use them as they see fit. For example, while methods are more explicit and often make code more difficult to read, they also make it easier to group a program's data and behavior in one place, which can lead to a more organized code base, which operates on an instance of a class method. It was not that difficult. And which part of this will be passed into the enchant method as the first argument self? As the first, none of these. It would be, yep, helm of module. The object itself will be passed in. Constructors, things to create a class. It is rare that in the real world to see a class that defines properties the way we have been doing. Okay, it is more practical to use a constructor in Python. Okay, a constructor, something that will return a class. If you name a method in it, that's the constructor, and it is called a new object is created, and it is called when a new object is created. So with a constructor, the code would look like this. Mhm. Inside the class indentation, I define a method called init, and that takes in self, the object itself, and puts name, armor, and number of weapons in the self. Now we can make the starting armor and number of weapons configurable with some parameters, right? Soldiers. We can pass in stuff and right, yes. First is the parameter, and the others are the things that are defined here. Okay, whenever calling a method. Hmm. So is the init especially ordained by the language itself, or it is just what we agreed on should be the name of the method that will act as the constructor? Yes, that is ordained by the class, because here we are passing in the arguments to the class as if class was a function that returns something, and we have defined that it is agreed upon in Python that the method which you define and named as init will be used for these purposes. That is, a method like this will be called whenever you call the class as if it was a function. Then this method will be called and it will act as a normal method would, and whatever happens to self will be returned through this method to this thing. If that is the case, then let's check a few things. And class.py and class are class and said class.py. Class our class will take def init definite shit. Okay, that is cool. Here it says that this syntax, I suppose, means that this is going to return none, which is cool. Num1, num to num3. So what I'm trying to do here is seeing what is returned by this thing. Wait, no. What is returned by this thing? It will return self, and if I do self equals 1, num3 is not accessed, doesn't matter. And if I were to do instance equals our class and call it upon 1, 2, 3, and then print instance, I should see 1, or it's 9 in this case, not print f, print class.py. Shit, my bad. Class.py. My bad. This Python 3 class.py. It says that this is an object. Okay, and this is an object. So self dot init dot eq dot. Okay, but if I were to do self dot num equals this, and here, then I would see num variable. What is dict? Does dict mean? Okay, what are the things that are variables? Stir dictionary which has value any. Python 3 class.py. Yep. So dictionary is the thing that returns everything. So in class.py, and if I were to do this here, and let's see what happens. Empty dictionary, because there is nothing in it. So the init method takes in parameters and stuff like any function would, any method would, and it can put in stuff to the self, and that is what will be returned by this function when calling the class in this manner. Add a constructor to our wall class. It should take depth, height, and width as parameters, like it does here, and set them as properties. Compute an additional property called volume, which is volume is the depth times height times width. That is very complicated formula. Self dot depth equals depth, and self dot height equals height, and self dot width equals width, and then def what will it be called, volume, which does not take anything, it just returns. It does take in self, by the way, just saying self dot height into self dot width into self dot depth, and let's see, run, and everything failed. Okay, volume, volume, yes, height, depth, width, volume, volume, depth times height times width. It should take a depth, height, and width. Depth equals depth, height, height, dep, height into self dot width into self dot depth, and compute an additional property. Compute an additional property called volume. Okay, my bad, my absolute bad. Self dot volume equals depth into height into width, and now run. Now it does work. Moving on, constructor quiz. All right, this takes in stuff and does this, and this takes in self, and speed is 10, subtracts speed, and then returns speed. In Python, what is the name of the constructor method in net init with underscores, two underscores before and two underscores after. Multiple object. Let's see.
Multiple objects. An object is an instance of a class. Let's look at what that means. In object-oriented programming, an instance is a concrete occurrence of any object. Instance is synonymous with object, as they are each a particular value. Instance emphasizes the distinct identity of the object. The creation of an instance is called instantiation. Wikipedia. So for our wall class, I can create 3 different instances of the class. Or in other words, I can create 3 separate objects. Wall Maria equals wall 1, 2, 3. Wall Rose equals wall 4, 5, 6. Wall Sam equals wall 7. In the example above, the variables are instances of the wall type. Assignment. Take a look at the brawler class and the fight function provided. In the main function, create 4 new brawlers with the following stats. 1. Name, Aragorn, speed 4, strength 4. 2. Name Gimli, speed 2, strength 7. 3. Name Legolas, speed 7, strength 4. Name Frodo, speed.
Okay. Create in this thing, create 4 new brawlers with the names the 4 new brawlers. Okay. Wait, yep. Where do I have to create? In the main function. Okay. Okay, here I am calling the main function. Here comes the stuff. Aragorn, Gorn equals brawler. Yep, call brawler with speed name. Okay, name Gorn, Aragorn, and shit, that has to be a string, right? That is a string now, and then comes speed, and then comes strength. So 4, 4. The second one is Gimli equals brawler. Gimli, speed is 2, strength is 7. Then is Legolas and brawler. Legolas, speed 7, strength is also 7. And then Frodo equals brawler, which is Frodo, and speed is 3, strength is 2. And then call fight twice. The first fight should be between Aragorn and Gimli, right? Fight. Power. What is power? Oh, power is also initialized in the start. First fight is between Aragorn and don't fight. I have no enemy. Then the second fight is between Legolas and Frodo. Frodo, brother of Michael Corleone. Yay! Submit, that should work, and that does work. On object quiz, which one of the following is true? Okay, and I have an object which is initialized like this. It takes in 3 values, and those 3 are put in the object itself, and then there is a get speed, which takes in self and returns to speed. Soldier like this, and soldier one name, and then soldier one get speed. Which of the following is true? An object is an instance of a class. Yes, a method is an instance of a function. Nope. A function is an instance of a method. Nope. A class is an instance of first one. And then archers assignment. Complete the archer class. Create the constructor which should take the following parameters in order and set them as property. Okay. What is it? Name, health, and number arrows. Self dot name equals name, and self dot health equals health, and self dot num arrows equals num arrows. And then that is done. Second, complete the get shot method. It operates on the current archer instance. It operates on the current archer instance. That means it just takes itself. And if the current archer has health left, remove one heart health from the current archer. After the above, check if the archer's health is zero. Expect raise the exception. This is dead, where this is the archer's name. Okay, let's see. If self dot health is greater than zero, then self dot health minus equals one, and then if self dot health equal zero, then raise exception formatted string. And where what is the format? The thing that I want to print is self dot name is dead, just like got this dot is dead. And then shoot. What is shoot? Finish the shoot. Finish like Finland. Linus Torvald is finish, I suppose. Finish the shoot method. It takes an archer instance as the target input. Okay. If the shooter has no arrows left, raise the exception, can't shoot, right? Otherwise, remove an arrow from the shooter. Print one shoots from two, where one is the name of the shooter and two is the name of the targeted archer. Call the target's get shot method. That makes sense. So self and target. If self dot num arrows equal zero, then raise exception formatted exception that self dot name can't shoot, and otherwise here because it will raise an exception, it will go out of the context, so I do not have to write the other part in else. Otherwise, do self dot num arrows minus equal to subtract one from it, and then do print. Then I have to print, right? Yep, print f the name of the shooter, self dot name shoots the target dot name, right? And then target dot get shot, or got shot, and that should be it. Run, and two fails and one passes. That is not good. King Richard has one health and one arrows. This has two health and one arrows, and King Richard shots King Prince John. Prince John has two health and one arrows, two health. Okay, exception. King Richard is dead. No exception raised. King Richard is dead. I raised exception. If health equals, when do I have to raise the dead exception? After above, check if the archer's health is zero. If the archer has health left, remove one health. Okay, if health becomes equal to zero, then raise this exception, which is cool. Which is cool. Wait, what? Yes, if health is greater than zero. My bad. My absolute bad. And that does work. Submitting code. Moving on to the last lesson in this part. Class variables versus instance variables. So far, we have worked with both class variables and instance variables, but we haven't talked about the difference. Class variables, instance variables. Yes, class methods, those are called class methods as opposed to instance method, and class methods can be accessed from the class itself as opposed to being a part of their instance of an instance of that specific class. Let's see. People. Uh, Instance variable. Instance variables vary from object to object and are declared in the constructor. This is an instance variable, but if I were to say that, let's say something like this, self dot, no, 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 no. This thing, this element equals ice. This thing belongs to the class itself. I can do dragon dot element to get ice. They must have done it. They must have done. Yep. Here it is done. Dragon dot element and dragon dot element equals fire, which changes the instance of the class. The instance of the class. No, it changes the variable that belongs to the class. Wall this right call initialize an object, make height 20, print south wall height 20, north wall right 10. So even though you changed it, the height here, it only gets changed in the instance of that class whose height you changed. It does not affect the variable that belongs to the class. That belongs to the class, yes. It only changes the variables in that particular instance of that class. Then here I have class variables remain the same between instances of the same class and are declared at the top level of a class definition and are declared at the top level of a class definition and are declared at the top level of a class and are declared at the top level of a class definition that is class declaration that is outside of any method like the way that we were doing before. Here height is 10, south wall print height this, and if I do wall dot height equals 20 and now I print it, it changes. In other languages these types of variables are often called static variables. Variable fields and properties. The term instance and class variables, field, property, and attribute are used interchangeably. What are the terms? Instance, class variable, field, property, attribute are used interchangeably and usually refer to the same concept in language that supports some sort of object-oriented programming. Here is a quick reference for some popular languages. In Python, class variables are called class variables, instance variables are called instance variables. In Go, both are called field. In JavaScript, both are called properties. In C++ and C Sharp, class variables are called static field and instance are field and static Java. I know Python. I don't know Go. I know JavaScript. I'm learning C. I know C a bit. I want to learn Go. That is going to be amazing. Which should I use? Generally speaking, stay away from class variables. Just like global variables, class variables are usually a bad idea because they make it hard to keep track of what parts of which parts of your program are making updates. However, it is important to understand how they work because you may seem see them out in the wild. You may see them out in the wild. Yep. Assignment. Some lazy code that's managed by another development team is causing some bugs in our team's class. We can fix it by using instance variable instead of class variables. We can fix them by using instance variables instead of using class variables in the main function that our team isn't responsible for. Line dragon.element equals fire should not affect our existing dragon instance. We want our users to specify each dragon's element type when they create a new dragon with the constructor. So I can do this self dot element equal element and remove this run that I feel like is correct. That is correct, and that this chapter is completed. Employee management challenge. What is the challenge? Get name. Is that it? Okay, I am not going to read the challenge and I'm going to do it anyway. And let's see how that works. Self dot Not that it is very complicated. It seems straightforward. Self dot last name equals last name and self dot id equals id. Self dot position equals position and self dot salary equals salary and get a name. I suppose it wants me to return self dot first name plus self dot last name with something in middle, of course, something like a space or something. Let's see, run. No, that is wrong. John Carmack, the man who created Doom, expected John Carmack. Actual name John Carmack. Expected employees 1. Why what? Self.id equals id position salary employee. Why is there a question mark there? Company name. Initialize the following class variables. Okay, there have to be a few class variables. Um, employee dot company name equals that is a nice company name. Age of Dragons Inc. I don't know what Inc. means. Employee dot total employees is 0. Right, and whenever I see this, then I will do employee dot total employees plus equals 1. Is that does not work. Employee dot company name equals this name employee is not defined. Okay, because this is and here this and this total employee not defined. Let me do employee dot total employee. That does work. Now moving on. Library. Wizards are having a hard time keeping track of all the books in their library. They need your help to create a library system that will allow them to add, remove, and search for books. Magical incantations to find books have unfortunately been unfortunately not been invited yet. Challenge. You have been tasked with writing the code that the wizard for the library. And okay, that is just optional. So, and probably I can easily do that. Encapsulation. A new aspect. Shit. No shit. Okay.
Encapsulation. Encapsulation is the practice of hiding complexity inside a black box so that it's easier to focus on the problem at hand. The most basic example of encapsulation is a function. The caller of a function doesn't need to worry too much about what happens inside. They just need to understand the inputs and outputs.
Hmm.
Acceleration equals calc acceleration, initial speed, final speed, time. To use the calc acceleration function, we don't need to think about every individual line of code inside the function. We just need to know that if we give it the inputs, initial speed, final speed, time, then it will give us the correct acceleration as an output. Public and private. By default, all properties and methods in a class are public. That means that you can access them with the big operator wall.height equals 10, print wall.height. Private data members are how we encapsulate logic and data within a class. To make a property or method private, you just need to prefix it with 2 underscores. Def init self armor magic resistance. Self score armor equals armor. Self dot more magic resistance. Def get defense self. Return self armor plus self dot magic resistance. Front wall equals wall 1020. This results in an error. Print front wall dot your armor. This works.
Okay. They are private and public variables, or properties, or methods, everything. We do this because It, he said that encapsulation means hiding details, and while working with it, you do not have to worry about the underlying details. But doesn't that just mean abstraction? What is the difference between encapsulation and abstraction? Abstraction. Let's see, encapsulation and abstraction are both fundamental concepts in OOP. Encapsulation, data hiding. Encapsulation is the practice of hiding the internal details of an object and only exposing necessary parts through well-defined interfaces. Example methods purpose: it ensures data integrity and prevents direct modification of an object's state from the outside world. How it works: uses private, protected, and public to the abstraction, hiding complexity. Okay, so first one means hiding details, and second one, wait a minute, I'll be right. I am back, and shit, I cannot hear the music. Yes, I can hear the music if I listen carefully. Open io. Increase it only a bit. And I literally don't know why this is here. Delete from library. Move to win. 7 years old, that is a good song. And yep, now where we were. Abstraction specifically means hiding complexity so that you do not have to think about implementation, and this means data handling, so you do not have to think about how data is manipulated. Doesn't that mean hiding complexity? Okay, encapsulation doesn't mean that the underlying thing is very complicated. It just means that you don't do not have to think about whatever it is. And it might be complicated or it might not be. But abstraction means giving you a high level interface to work with something complicated at the low level. That is a good enough understanding, I guess, for now. Now, public and private, and public private properties start with these two underscores, and it would be amazing to rechange my Instagram name and make it start with two underscores. We do this because in this example, armor and magic resistance are implementation. I guess we cannot write a username with two underscores. That starts with an underscore. We do this because in this example, armor and magic resistance are implementation details. After creating a wall, they don't matter anymore. Now the game developers can just get defense, can just call get defense and worry about how it is calculated under the hood, and not worry about how it is calculated under the hood. Complete the wizard class construction, set two private properties, stamina and intelligence. Is stupid. Self dot stamina equals stamina, and self dot underscore underscore intelligence equals intelligence, and I guess self dot name is not like that. It is just a normal property and some method. Set three public properties: name, health, and mana. All right, self three public properties. Name is a public property, and mana is 10x the value of whatever is intelligence is, and self dot health is 100 folds the value of stamina. So only a little bit of stamina can mean quite a bit of health. Zero failed, two passed, and yep, that works. No security. Let's see.
Not security. Encapsulation is the practice of hiding code complexity inside a black box so that other developers working with the code don't have to worry about it. To be clear, it does not make the code more secure in a cryptographic or cybersecurity sense. That's a point I was personally confused about when I was first learning about private and public class members. Encapsulation is about organization, not security. Encapsulation is like folders in an unlocked filing cabinet. They don't stop someone from peeking inside. They do keep everything tidy and easy to find.
Okay, encapsulation means organization, not safety and security. Okay, private properties are good for keeping password safe. False. Next, not security. Okay, encapsulation is a great way to make it easier for the developers to work with your code. True. And then wizard duel. Let's have ourselves our wizard duel assignment. Complete the following methods to do to the wizard class. Get fireballed. Uh-huh. Removes should remove 500 health from the wizard. Okay, and drink mana portion should add 100 mana to the wizard's reserves. Both methods should operate on the instance of the class, not the class itself, not the class itself. Yep, and they take on inputs and return no explicit values. Okay, so therefore this removes 500 from health. If it removes 500 from health, should it also remove the equivalent stamina? Self dot health minus equals 500 and self dot underscore underscore stamina equals, wait, I have to subtract stamina is equals just equals self dot health divided by health divided by 100. Suppose that is correct, and then self dot mana plus equals 10 100 and self dot intelligence plus equals, or maybe I'm just making it more complicated than it needs to be, mana multiply by, or more correctly divided by 10. Maybe that is wrong. Nope, that is not wrong. If I were to remove these two, would it be wrong then? It would not be wrong then still, so it was just over engineering stuff. And then encapsulation in Python. Python is a dynamic language, which means type of a variable can change over time, and that makes it difficult for the interpreter to enforce some of the safeguards that languages like Go do. That is why encapsulation in Python is achieved by mostly by convention rather than by force. If there is nothing inbuilt in force holding stuff in place, it is just by convention you have to write it out. Prefixing methods and properties with a double underscore is a strong suggestion to the users of your classes that they shouldn't be touching that stuff. Okay, so class.py, and let's say this takes a number, and then self dot num1 equals num1 and no semicolon, self dot underscore underscore num2 equals num2 and self dot num3 equals num3, and these are not accessed, doesn't matter. And then this, and then I guess I can simply do num1 to 3. Okay, that is cool. 2 3, and if that works, then yep, has no attribute num1 num2 num3. If I were to do remove these and then do this, then I should at least see the value for num1. Python 3 class, yep, I see the value for num1. Yeah, I cannot access things that are private. There are, which is they said in an earlier lesson. So no shit, Sherlock. Not very intelligent thing to discover. The double underscore makes this a private property, but it is not strictly enforced. There are hacks to get around it. Uh-huh. How? Oh, I can just return it in a function like that. Python enforces encapsulation by fully preventing developers from touching the private property. Nope. I can. There are workarounds. There are workarounds like this, and that is why they mean that there are some ways to access private properties, some indirect ways. Encapsulation. Other languages like Go have more strict ways to enforce encapsulation. True. I think that is what you said here. Okay, so Go has a stricter encapsulation. Python does not has a stricter encapsulation because there are workarounds in Python in which you can indirectly access private properties, but you cannot directly access them. It will give you an error if you were to directly access private properties. Let's give our wizard the ability to launch firewalls at each other. Complete the following methods. Create the cast firewall method. If there isn't enough mana to cast a firewall, see firewall cost at the top of the file. This, this 50. Raise an exception with the message dash cannot set firewall. This is the name of the wizard. Okay, cast firewall if self dot mana less than firewall cost. If it is less than, raise exception which says a formatted exception which says self dot name cannot cast firewall, and else if that does not happen, then right, and then if the wizard has enough mana, reduce the mana power. Self dot mana minus equals firewall cost, right, and then call get firewalled by the firewall cost, and right, and call get firewalled on the target wizard. So target wizard dot get firewalled is alive. What does is alive do? Create the is alive method which returns true if the wizard's health is greater than 0 and returns false otherwise. Okay, so return self dot health greater than 0. If it is greater than 0, it will return true, and if it is not, then it will return false. Get firewalled and mana portion run. 2 failed. Yep, that is correct. Like no failed, 2 and no failed. That is optional. You can just skip to the next chapter. I will skip to the next chapter, abstraction. Let's see. Abstraction helps us handle complexity by hiding unnecessary details. By hiding unnecessary details sounds like encapsulation, right? Yes, they are so similar that it's almost not worth worrying about the difference. Almost. Abstraction versus encapsulation. Abstraction is about creating a simple interface for complex behavior. It focuses on what is exposed. Encapsulation is about hiding internal state. Okay, encapsulation is more about how you hide what you have, and abstraction is more about what you give from what you have, among what you have, what you show. I guess that is good, and over time, it is like how do you judge the gender of a small chicken? You get it over time. Encapsulation is about hiding internal state. It focuses on tucking implementation details away so no one depends on them. Abstraction is more about reducing complexity. Encapsulation is more about maintaining the integrity of system internals. Are we encapsulating or abstracting? But almost always we are doing both. Here is an example of using random library to generate a random number. Here, this is encapsulation. I do not have to worry about how the random function works and gives me number. That is abstraction, and I cannot get access to stuff inside that function. That is called encapsulation. Generating random numbers is a really hard problem. That is why there is a chapter in Art of Computer Programming on generating random numbers. The art of computer programming. Wikipedia, yep. Generating random numbers is has it been released? Okay, techniques. That is planned. And parsing techniques, that is going to be amazing. A really good chapter. But about random numbers, oh, it is just chapter number 3. Chapter 3 is all about random numbers. That is cool. That is cool. Chapter 7 and 8 is released in several sub-volumes. Please complete them, Mr. Kanut. Small. Shit. Font too small to read. That is how programming is done. And again, uh, the song, the music, the thing. Yep, getting random numbers is a really hard problem. The operating system using the physical hardware of the computer to create a seed for the randomness. However, the developers of the random library have abstracted that complexity away and encapsulated it within the simple rand range function. We just say, I want a random number from 0 to 4 in the library, and the library does it. When writing libraries by use for use by other developers, getting the abstraction right is crucial because changing them later can be disastrous. Imagine if the maintainers of the random module changed the implementation parameters to the range function, it would break code all over the world. A human class and its constructor have already been created for you. We don't want the other game developers using our human class to have to worry about how humans move. We abstracted that away from them by encapsulating the private position x, y, and speed variables. Now, complete these methods. Move right, what does it do? Um, Move right adds human speed to its x position. Self dot pos x plus equals self dot plus condos speed. Right, and then move left subtracts the human speed from its x variable, and move up adds human speed to y. Move down reduces from y, and get position returns the x and y as a tuple. Okay, self dot pos x pos x minus equal self dot speed, and here self dot pos y plus equal self dot speed, and here also self dot pos underscore pos y minus equal self dot underscore speed, and here return as a tuple self dot pos x comma self dot underscore pos y. That I guess should work. No, that does not work actually. Self dot pos x pos pos y. Track most recent call. What is the problem? Attribute human object has no attribute POSIX. This thing right here, POSIX, that is right there. POSIX. Okay, my bad. This that should work. It does work. Submit and move on. Abstraction. That woman is in the office. Steve Carell. Abstraction versus encapsulation. You may have noticed already, but abstraction and encapsulation are basically the same thing. They just emphasize different aspects of the same thing. Yep, flip flop. No, two sides of the coin. Corporate needs you to find the difference between this picture and this picture. They are the same picture. Abstraction is about reducing complexity. Creating good abstraction is particularly crucial when you are developing libraries for other developers to use. For example, the built-in POW function in Python is an abstraction that hides the complexity of calculating exponentials. It is very complicated. POW is it magics? Somewhere code that does something like this exists and is called when you do POW. This it keeps multiplying it, right? Which is not a good reason to hide. Which is not a good reason to hide implementation detail. Good to keep code simple and easy to understand. That is a good reason to keep passwords away secret. That is also a good reason to hide complexity from logic. complex logic from users of your function and classes. That is also a good reason to avoid making breaking changes for the users of your code. For the users of your code, that seems like shit, which is not a good reason to hide implementation detail. So, which one of these is a reason that you should show your implementation to keep code simple and easy to understand? That is a good reason to hide. It's not a good reason to hide. To keep passwords secret. That is why you are hiding to hide complexity from users of your functions and classes. To keep passwords secret, because passwords aren't actually secret. They can just be reached. If you want to keep passwords secret, you can do encryption. That would be much better. Abstraction emphasizes dash and encapsulation. Abstraction emphasizes simpler interface and making users easy, hiding implementation detail, making users easy. This abstraction focuses on what you show, making stuff easy, and the other one, the next one, encapsulation means more of hiding what you have. Sprint. In the game, we are making Age of Dragons. I forgot. Humans can sprint, allowing them to move twice as fast. However, sprinting requires stamina. Each time a human sprints, it loses stamina. Once it is out of stamina, it objectifying a human, it can no longer sprint. Complete all the missing methods. Right. Complete the private helper function methods, which are intended to be used by the other four sprinting methods. All right. I think humans. Raise if cannot sprint. This thing. Raise the exception. Raise this exception. Not enough stamina to sprint if the human is out of stamina. Okay. If self dot. Where do I find sprint? Stamina. Stamina less than or equal to 0, then raise exception not enough stamina to sprint. Sprint. Yep, stamina to sprint. And use sprint stamina. Yes, this function remove one stamina from the human. Okay, self dot stamina minus equals 1. Right, and then for each of the sprint methods, these sprint right, sprint left, up, down, reason error if there isn't enough stamina to be used, and use raise if cannot sprint method. Use the stamina need to sprint. Use sprint stamina move twice in the direction of the sprint. Move twice in the direction of the sprint. So for I can use a loop which runs twice, and okay, I'm going to use a loop for I in range. But I don't have to use explicitly I can use underscore for this in range 0 to 2. Do this first try and catch. Okay, I can just do self raise if cannot sprint, and this will simply cause exception, and if it does not, then my code will reach this line. Use sprint stamina, but in which direction? Move right. Use the stamina needed to use the sprint. Use the stamina 1 point. Move twice in the direction of the sprint. Sprint right. You sprint uh, stamina and then self dot move right, and I'll just copy all of that, paste it here, make this equal to, instead of right, make this left, move left, and copy this much, paste it here, and move up. I guess up is our function. Up and down, yep, up and down, those are functions. And copy all of this, paste down, yep, and run to field. Okay, expected this error none, but got this error not enough stamina to run. Raise if cannot sprint twice. Move twice in the direction of the sprint. Move twice in the direction of the sprint. Methods. First, a human started at this thing. Therefore, the X position is 0, Y is 0, speed is 30, stamina is 3. Then it went left, sprint left, and sprint left, and then sprint left. What did it expect? It expected minus 120, but it got minus 60. By moving left once, it moves left. By sprinting left once, it moves left twice. I guess this line only has to run once, and not just this, but this line only has to run once. And yeah, that is it. This line only has to run once, and I can remove these and remove these. Yep, that should I guess work. Pass, yep, that does work. I have to reduce stamina only once. How object-oriented developers think. Classes in object-oriented programming are all about grouping data and behavior together in one place. An object-oriented programmer, ob object-oriented classes in object-oriented programming are all about grouping data and behavior together in one place. An object. Object-oriented programmers tend to think about programming as a modeling program. They think, how can I write a human class that holds the data and simulates the behavior of a real human? Data is the data points that you are giving it, and behavior are the methods which manipulate that data. To provide some contrast, functional programmers tend to think of the code as input and output, and how those input and output transition the world from one state to the next. From one state to the next. When a human takes a step, what is the next state of the game? Yep. Object-oriented human walk, self position plus one. Earlier state, new state. Next, human is walk, previous human. Both paradigms are valuable. Object OP isn't only pattern for organizing code, but it is one of the most popular ones. If you understand multiple ways of thinking about code, you will be a much better developer overall. OOP typically groups dash and dash into a single unit. Variables and constant functions and methods, data and behavior. That is correct. And next, OOP developers generally think of programs as someone else's problem, modeling the real world with objects, an I/O problem, a performance problem, modeling the real world with objects, modeling the real world with objects, modeling the real, or it could be I/O problem because of this thing. It takes in an input and gives out an output. See, their code as input output, but they are also modeling the real world and as an object. I like that one more. That is correct. That is correct. And now this is optional, and I'm going to skip optional. And now I am in guest mode. Inheritance, and let's see how long it is. It has 13 parts, and how much time have I been streaming for? It's been 1 hour and 25 minutes. hmm And then let's start. Wait, I thought that was TJ DeVries. Theo one. Polymorphism is the last topic, which also has just about 12 chapters. Let's go to inheritance and see we have made it to the whole thing of inheritance. Non-object oriented programmers like Go and Rust languages like Go and Rust allow for encapsulation and abstraction features as nearly every language does. Inheritance, on the other hand, tends to be unique to class-based languages like Python, JavaScript, and Ruby, to class-based languages like Python, JavaScript, and Ruby, Java, and Ruby. What is inheritance? Inheritance allows one class, the child class, to inherit the properties and methods of another class, the parent child. This powerful language feature helps us avoid writing a lot of code twice. That means dry. Syntax. Cow is a child is syntax to do inheritance, to implement inheritance. Here, cow is a child class that inherits from parent class animal. Animal has some things and class cow animal. So cow, the definition of cow takes in an animal. Okay. The cow class can reuse the animal class's constructor, the super. Right. This is the animal normal animal class that has a number of legs as properties. Then there is the cow class, which takes in the animal class itself, and then inside number of udders, it creates a animal class where number of legs are specified as four, and then does this. Okay, then it specifies its own addition on top of the animal class, and this is just the syntax of how it is used. So we don't have to worry about too much about oh, this particular syntax. In Age of Dragons, all the archers are humans, but not all humans are necessarily archers. That makes sense. So this takes this and get numbers. All humans have a name, but all humans do have a name. So here, I guess what I am supposed to do here is shit. Okay, since I'm in guest mode, I cannot change it. Yeah, that makes sense. That makes sense. Yes, I can just move on. When should I use inheritance? When there are a lot of objects that when there are a lot of classes that I have to make, and quite a few of those classes share a same property or a set of properties, and that I want those to be defined at a stable global scope, and then I can use inheritance. Inheritance is a powerful tool, but it is really a bad idea to try to overuse it. Inheritance should only be used when all instances of the class are also instances of the parent class. When a child class inherits from a parent, it inherits everything. If you only want to share some functionality, inheritance is probably not the best answer. Better to simply share some functions, or maybe make a new parent class that both classes can inherit from. All cats are animals, but not all animals are cats. Yep. It makes sense for animals to inherit from plants. Nope. False. It makes sense for cats to inherit from animals. Yep, true. animals and plants might inherit from a class called organisms. Yes, inanimate object organisms or inanimate objects. If you have seen two kitties and a vacuum cleaner, inheritance hierarchy, shorter than wood than harder than bar. There is no limit to how deeply we can nest an inheritance tree. For example, a cat can inherit from an animal that inherits from living things. A cat inherits from animal, and animal inherits from a living thing, which inherits from quantum mechanics. And that said, be careful. New programmers might often get carried away. You should never think to yourself, well, most wizards are elves, so I'll just have wizards inherent from elves. A good child class is a strict subset of its element. Strict means that strict good child means that it always has the same properties from the self world. An example of this is with private properties. A child class cannot simply access a private property of its parent class. It has to use a getter function. Getters. Yes, getters. Getters are a function to give access to the private properties to the outer world. I guess. Right here is an in constructor function and a private property called height, and get height returns height. Yep, that is the kind of exploit they said right in the start. And then wall super initialize a class, right, and self dot towers equals towers. Get towers height is self dot get height. Okay, it has to call the getter function of its parent class to get access to its private properties. Let's add a new game, and I guess I can just simply skip the assignment part. That is, yep, doing this is much better. Inheritance review. Example of inheritance in code. Good hierarchy is something like this. Yeah, where a good subset, a proper subset, means that none of the elements in the subset are outside of the parent class. Every element is inside. Yep. Real estate. All the properties of real estate are the properties of residential, and all the properties of residential are the properties of house. Imagine dog inherent from canine. Now a canine inherits from dog. The dash class uses super to call the constructor of the class. The dash class. Okay. Imagine dog inherits from canine. Yes, dogs are canines. That is cool. I thought canine is a breed. No, dog inherits from canine. So dog will call the constructor for of the canine class. First one is the answer. How many levels deep can inheritance infinite? Multiple children. Alright. This thing, let health, damage, name health and damage returns reduces health. Archer, super, init, right, and then shoot multiple tiles. So far we have worked with linear class inheritance, but usually inheritance hierarchies from trees, not lines. A parent class can have multiple children. That makes sense. Is that lagging? That seems to be lagging. And well, my face is not lagging, so that is fine. That is cool, and we can just move on. So I'll just skip. Well, I already know this. It is more common for an instance, and my skills will be more horned. H-O horn. What is the correct pronunciation? Horn. Have a horn. No. H. Horn. Okay. Fine. It is more common for an inheritance tree to be wide than deep. Okay, yes, that makes sense. You are likely to see an inheritance tree with a base class of organism leading through a chain of four. Yeah, you won't see something like that. If you do, run. Yep. Why inheritance tree often wide instead of deep? Because making it more deep makes it complex. Yes, we have talked about it earlier. In good software, a child class is a strict subset of its parent class. In a deep tree, that means the child needs to be a perfect member of all the parents types. That simply does not happen very often in the real world. It is much more likely that you will have a base class that simply has many children classes that are slightly different variations of the base and siblings. Inheritance trees are more wide than deep. Yep, and a class must have at least dash children and at most dash children. A class must have at least zero children and at most at least it can have zero and at most it can have infinity. Third, dragons. In Age of Dragons, the game grid. And this is just an assignment. That is cool. That is cool. I can just go to the next thing. Dragons, we have created a lot of classes in this code. Now let's write some code that uses them and escape to the next chapter. Is this polymorphism? While inheritance is the most unique trait of object-oriented languages. Polymorphism is probably the most powerful. Polymorphism is the ability of a variable, function, or object to take on multiple forms. Poly is many, morphism is many forms. For example, classes in the same hierarchy tree may have methods with the same name but different behaviors. Methods with the same name but different behaviors. And which method will be called depends on the input type provided to it. Take a look at this. Move, move. Okay, there is a class and dragon move, kraken move. Kraken swims, the dragon flies, the creature moves. And if I call for creature in this creature dot move, for creature in this, all right, this is a list of objects, and these are the initializers of those objects. The dragon and kraken child classes are overriding the behavior of their parent classes move method. Assignment, we are writing a hip box game step by step, starting with a simple rectangle. Complete the init method, configure the class to have manage the variables, and this that is simple. Get edges. Remember that with normal units, we are checking if xy point was within rectangle and dragon's breath to see if they were hit by the fire. With a dragon, because they are so big, you're going to check if the dragon's body, a rectangle, is within the fire, also a rectangle. The image below contains an example of the fire breath hitting a dragon. This is the fire, this is the dragon body assignment. In the next assignment, we will be writing the overlap method itself, but first you are going to write a method to find the edges of a rectangle. Edges of a rectangle. And these just getters. The coordinates have been made private members. We have two underscores to them, so we need to write getters. Yep. These are just four getter methods. After writing the getter methods, which are get left x, yes, get the one that is lower. Yep, yep. Uh, yes, we let's write the overlap method. It should check if this lower given overlap method rep, rep, representation. I guess that will print it. Overlaps. This one. This method calls these four on this rectangle also and on itself to find out if it is right or wrong. Check the rectangle overlap any part of the rectangle of the rect, including just touching or false otherwise conditions. And conditions must all be true if the rectangle overlaps or touches rectangle B. A's left side is on. A's left side is on or to the left of B's right side. Right. A's left side is on or to the left of B's right side. Then A's right side is on or right to B's left side. Yep. And yep. And so that means that they are in X coordinate, they are overlapping, but they could be anywhere in the Y coordinates. And that's what we're checking last two conditions. Which right after this is what I have to write, and this rectangle is what is already written. Let's bring all we have done together in Dragon class. The Dragon class should override the unit classes in area method. The unit classes in area method. Instead of checking if the center position of the dragon is in the given area, center position, we will check if its big dragon body overlaps with the given area. The dragon class should override the unit classes in area. Okay, in area. Wait. In area. In area. In area is in dragon is an instance of the in area thing class, and in area has its own is method in area, but it is overwritten by in area inside dragon according to these rules, right? And polymorphism and classic shape rectangle. Polymorphism in programming is the ability to represent the same interface function or method a signature for many different underlying forms. Data types. A class example is a shape. Yes, I will be doing calisthenics after this stream. A classic example is a shape class that rectangle, circle, and triangle can inherit from. Yes, with polymorphism, each of these classes will have different underlying data. The circle needs its center point, coordinates, and radius. Center point coordinates, and radius. The rectangle needs two coordinates for the top left and bottom right, top left and bottom right corners. The triangle needs coordinates for the corner. By making each class responsible for its data and its code, you can achieve polymorphism in the shape example. Poly means many and morph means form, many form. First one is the answer. And the main benefit of polymorphism is I can use the same method name to mean is to not mean different thing, but conceptually mean the same thing, but I can mess around with the details to match exactly the class on which I'm using that method. To write few lines of code in a class now, to hide the difference between subtypes from users of your code. Yep, that is correct. To give users of your code different function signatures for a single method. Nah, second one seems correct. To hide differences between subtypes. Yep. To enclose the complexity of your class behind getter methods. Methods on different classes can have the same signature. What is okay, my bad. I didn't read the complete thing. Yep, my bad. By making each class responsible for its own data and code, you can achieve polymorphism. In the shapes example, each class would have its own data shape method. This allows the code that uses the different shapes to be simple and easy, and more importantly, it can treat shapes as the same even though they are different. It can treat shapes as the same even though they are different. This allows code allows the code that uses the different shapes to be simple and easy. And more importantly, it can treat shapes as the same even though they are different. It hides complexities of the difference between behind clean abstraction. All right, here I have created two things, circle and rectangle for shapes. Draw shape, and I will see, yes, that is polymorphism. Using the same method, name in two different instances of a parent class. This is in contrast to the functional way of doing things, where you would have separate functions that have different function signatures, like draw rectangle and draw circle. Wait, what is a function signature? Yes, a function signature or method signature includes the name, inputs, and outputs of a function or method. For example, hit by fire in the human and archer classes have identical signatures. Hit by fire, they have the same name, same input and output of a function. All right. Both methods have the same name, take zero inputs, and return integers. If any of those things were different, they would have different function signatures. Here is an example of different signature. Human hit by fire, name is same, but input is different. Yep, signature is different. The archers class hit by takes an input damage, which is used to calculate the new health. This is a different signature than the humans class hit by fire method, which takes no input. Calling two methods with the same signature should look the same to the caller. Calling a function with the same signature should appear same to the user caller. When overwriting methods, use the same function signature. If you change the function signature of a parent class when overwriting a method, it could be a disaster. The whole point of overwriting a method is so that it doesn't have what different things are going on inside the method of differentiation. Yep. Methods on different classes have the same signature. On different classes, false, because not always. They might not. If this and this have the same signature, false. Nope. It is a good idea to use dash when overwriting a parent's method from a child. The same function signature. Now this operator overload, that is correct. Plus for here, and this is the exact example that I gave. Another kind of built-in polymorphism in Python is the ability to override how an operator works. For example, the plus operator on this, and I can write this in it. Custom classes, on the other hand, don't have any built-in support for those operators. This will give error because it is not defined what to do when it is being added. However, we can add our own support if we create an add self other method on our class, on our add add right. If I create add method in our class, that will be called when I use plus with an instance of the object, like here. And first is myself, and the second is the other one on which this is being called, the other object on which with which add is being called. And this is what is supposed to do, and this is what it is supposed to return. Now, when this plus p1 plus p2 is executed under the hood, the Python interpreter just calls this. Yep, and not gonna do the assignment since I cannot do the assignment. Operator overload and add sum for sub multiply power true div float div mod shift right shift. I can overload fucking everything, which is the inverse of multiply divide true div. And this is this is the final requirement. Okay, overriding built-in methods. Overriding riding built-in methods. Built-in methods. Okay. Last but not least, let's take a look at some of the built-in methods we can override in Python. While there isn't a default behavior for the arithmetic operators like we just saw, there is a default behavior for printing. A default behavior for printing a class. When you are by default printing a class, it will be printed as in like with the with angle brackets, and inside it is written class or something. See this, the name of the class, and where that object, that instance of the class is stored. That is the pointer, the address of that thing. That is how you print it by default. But you can change it like this, right? And because when print is called on a class, the stir function is called on that object, on that instance of that class, which is called an object, and whatever is returned by that will be printed on the screen. And that is what it is. You can move, and yep, that is optional, and you can skip it. And basically, we have done it. Object-oriented programming